So there's one final type of problem to discuss in which we'll need to use ratio and proportion. When medications are added to an IV solution, and those are relevant to solving the problem, we'll need to use ratio and proportion. We might be calculating for a flow rate, or we might be calculating for some sort of amount to be infused. Let's take a look at an example. If we have 12,500 units of heparin in a liter bag of D5W, which is infused at a rate of 40 milliliters per hour, how long will the bag last? Well, looking at this example, the fact that there are 12,500 units of heparin that are added to the liter bag is not relevant to solving the problem. So in this example, we're being asked how long the bag will last. So in that case, we're simply looking that we have a 1 liter bag of D5W at a rate of 40 milliliters per hour, and we have learned to calculate that by taking the volume in the bag and dividing it by the flow rate and coming up with a solution of 25. Remembering what we said, that's greater than 24, so truly this bag, we would need to be prepared to replace this bag at 24, but you would calculate, given a test answer, you would say 25 hours. Again, being aware though that in the real world, a bag wouldn't be left hanging greater than 24. Now, in that example, I'm just emphasizing the fact that a lot of times there's extra information thrown in that you don't need, and you need to know what information to pull out. Let's look at a different take on this example and see that the amount of drug is very relevant. The physician orders 12,500 units of heparin in a 1 liter bag of D5W for IV infusion. The rate of infusion is 500 units over 1 hour. What is the rate of infusion in milliliters per hour? At this point, that amount of drug in the bag is very relevant. And really, the way to solve this type of a problem is using ratio and proportion. And we need to remember when we're using ratio and proportion to ask ourselves, what do I know versus what do I need? So in setting up the proportion, we also need to remember that the units always need to be in the same order on the left and the same order on the right side of the equation. So in this example, we know that we're solving for milliliters per hour. The problem tells us that. So that has to be X. That has to be our unknown. So in this problem, what do we know? We know that we have 12,500 units of heparin in 1,000 milliliters of D5W. That's a known. And I always like to write the units. It helps to clarify when solving this. So we have 12,500 units in a 1 liter bag, which is the same as 1,000 milliliters. Because again, we can't mix units. So the next step is to ask ourselves, what do we need? And what we need in this problem is we need to infuse 500 units over 1 hour's time. But the volume that we need to infuse is unknown. So keeping again with, we're going to have on this side units to milliliters. We can't have anything else. We know that we need to infuse 500 units, but we don't know what volume that's going to be. At this point, this should just look like our means and extremes. So we know that we need to infuse 40 milliliters in order to infuse 500 units. So our answer then is 40 milliliters per hour. So you might want to pause here and calculate the next example problem. and I'll show you how to work this. An order is for heparin IV to infuse at 1,000 units per hour. What will be the flow rate in milliliters per hour for a 500 milliliter bag of D5W with 25,000 units of heparin? So again, in this problem, what is the known? Well, we know that we have 25,000 units in 500 milliliters of fluid. That is our known. But what is our unknown? We're being asked what's the flow rate in milliliters per hour if we are to infuse 1,000 units per hour. So again, we're going to have to keep our units in the same order, and the problem tells us that we're going to be infusing 1,000 units, but it's an unknown number of milliliters. So again, multiplying means and extremes. And then we determined that we're going to be having to infuse 20 milliliters in 1 hour to achieve infusing 1,000 units.